Hello everyone. My name is Utkarsh Raj, and welcome to my YouTube channel. And as you know, we are currently doing our top interview 150 question series. And today we are going to do our next question, which is best time to buy and sell a stock too. So, in previous video, I have solved this question, and now we are going to solve its next part. So, now let's move on to the question. So the question states that you are given an integer array prices where prices I is the price of a given stock on the ith day. So this question is similar to the previous one where we have given a input array prices where each price is the price of ith day, price of that stock on the ith day. So let's see the question what we have to do. On each day, you may decide to buy and or sell the stock. You can only hold at most one share of the stock at any time. However, you can buy it then immediately sell it on the same day. So, like previous question, where we have to buy ones and sell ones to find the maximum profit. In here, what we have to do, we have to find different days to buy and sell the stock in order to maximize our profit. So we can buy multiple times, sell multiple times, so to maximize our profit. Here, 2 points which we have to take in consideration that we can at most withhold or take one stock at a time. So whenever we buy the stock, then unless we have sold it, we cannot buy another stock. And the one point is given that we can buy a stock on one day and sell it on the same day. So it is possible, and we have to maximize our profit which we can achieve. So this question is a clear indication of recursion because here it is he wants to find the maximum, and as you know, whenever we have indication to find maximum or minimum and we have multiple path which we can follow to achieve, then we have to use recursion to find every possible path and find the maximum and minimum. So now let's see the some approaches which we can follow. So the first is going to our recursive approach. So what we are going to do in this, let's take a simple lookout. So the recursive function checks calculates the maximum profit using a buy sell decision approach and memorization to avoid redundance calculation. So this memorization part we will do it later after achieving our recursive function. So we are going to make a check recursive function which will be calculating our maximum profit by checking two conditions buy sell. For every stock we have two decision to make, either buy it or sell it. So this is our basis of our recursion. Now it starts at current index and decision flag. So it has two parameters, index and flag. And index is the index on indicating the day on which we are deciding for our stock either to buy it or sell it. And the flag is deciding that does we have a stock in our hand or we do not. That means that previously we have bought any stock or we have no stock in our bank or in our hand, and its result is also memorized. It is returned. If the result is already memorized, it is returned. So if the result is already stored in our memorization, so we return it. We do not need to do anything. But otherwise, to if calculated, it calculates the maximum profit by comparing two scenarios. So if it is not present on memorization, we have to calculate it, or basically we have to write our recursion. So this is the how recursion is going to be written. So it is going to check buy or not buy on the current day, sell or not sell on the current day based on our decision flag. So based on decision flag, that means previously we have bought any stock or not, we are going to use these approaches. The function recursively calls itself for the next day and updates the memorization table. So function is going to recursively call for the next day and it is also going to update the table. So this is the second part, but I have included it so that we can understand it alongside. Finally, it does the maximum profit. So this is the overall structure of our function which is going to be. Now let's assume how it is going to create a stack space, or it is going to work in a stack space. So let's assume this question, which is price is given. So first what happens, we are going to call a check function, which is our recursive function, going to call our recursion, and it starts with our prices, which is our array, price array, and with the first index. So we are starting with this index, and we are giving that we have not bought any stock. So at this position, when we are first day, we do not have any stock in our hand. So we have provided 0. So we are indicating 0 as no stock and 1 as a stock. So what happens if it goes into our recursive part? So it is going to call for two. it has two options to do. So first, it is either it can buy this or either it do not buy. So this is the first, buy or not buy on the current day. So the for 7, it has two options for which it has called two recursive calls. First is this and second is this. So here you can see we have moved to the second position. We have called the recursion for the next position, and with a parameter that we have buy this stock. So we have buy this stock and moved to next position. And in this, what we have done, we have not buy, we just skipped it and moved to this position with the parameter that we have no stock in our hand. So that's how our recursion is going to work. Now let's try to understand more better. So what we have decided to, let's create a function and let's make it check. So what it contains a factor, and if we have current and we have decision parameter. So decision, it is the parameter which is giving indication that our previous we have previous stock or not. So first thing we have to consider is that what is our going to be our parameter or condition where our recursion is going to stop. So let's assume that our recursion is at this last position, and after recalling it moves to next position, which is the size equals to the size of our array. So let's assume that in these previous days we do not buy any stock. So if do not buy any stock, so at final day what happens? We have not bought any stock, so the profit is going to be zero, because if we do not have any stock, so we cannot sell it and do not gain profit. Now let's assume a scenario that we have bought any stock, this one, any stock we have in our hand. So what happens? We have skipped our day. So let's assume that our stock market goes to Friday, Saturday, Sunday is off. So let's assume this day is Saturday. So we do not have sold that stock. So what happens? We do not have any profit. So our profit again is going to be zero. So that's why we have our condition that if our current is equals to prices dot size, then what we have to return? Then we have to return zero. Now we have to run our recursion. We are going to write our main function which is recursion. So now let's assume that what we have to return, we have to return the maximum profit. So let's take it as maxi equals to zero. Let's assume maximum profit to be initially zero. Now based on our decision parameter that either we have bought any stock or not, we are going to write our function. So let's assume that we do not have any stock today. Okay, zero, we do not have any stock. So we have two options as we have seen our algorithm, that first either we can buy or not buy. So let's first assume that we buy that stock. So what happens when we buy any stock? What happens to your account? Let's see that when we buy any stock, our account get debit. So we will do minus prices current and plus then we have moved to this part, and let's call the next recursive call for the next day. So we are going to call for next day check. We are going to supply prices next day current plus 1, and we have buy the stock, so we will include 1. Now for second option, and in here we do not buy any stock. So we when we do not buy a stock, so our account has do not any changes. So let our changes equals to 0. It is for reference that there is no change. And now we call for the next day. So check prices comma current plus 1 comma 0. So we do not buy, so our d is equal to 0. Our decision is going to be 0. Now what we have to do, we have to return the maximum. So if we buy on that day or not buy, we have two directions. So which one gives the maximum, we are going to get accept that. So our maxi is going to be max of x comma y. Okay, similarly we are going to write our else part. In S part, similarly we have X. Now we have two options. When we have buy a stock, we have a stock, then we have two options, either sell it or not sell it. So now let's assume we sell it. So whenever we sell a stock, what happens? The price money amount comes to our account. It increases our balance. So we are going to do simply prices current plus, and now when we have done that, we have moved to next step. Check prices next day, and we have sell that our so we have sold our stock. So what happens? We do not have any stock, so we include 0. Now for our next option in which we do not sell our stock, so what happens? We directly move to next day. Check prices current plus 1, or we do not sell, so we have already a stock. So this is the scenario. Now we have to again find the maximum. What is going to be our giving us the maximum output? So we take it. Okay. Now we are going to return this. Return maximum. Now we have to supply the parameter. So here we have to return for the first. We are writing for the first position. So we are going to return and supply for check our prices first index, and we do not have any stock, so we are going to put 0 because we do not have any stock initially. So this is the whole code. Now let's check is everything okay or not. Okay, so it is accepted. So our recursive part is complete. Now let's include the memorization part which we have already read. So let's understand what is this. So what we are going to do, we are going to store the memorization. We are going to memorize the sum of the calls, because maybe this call is going to be called multiple times in here. This call may be called multiple times this with these fixed values. So we are going to store that value in an space so that we can use that if we get that value or call. So we are going to use a 2D vector. So let's create a 2D vector, and let's take it as v, and let's initialize it. So we have 2D vector of length and okay, let's take me int n equals to prices dot size. So we have length n, and we have another 2D where we have length 2, and let's first initialize it at -1. So we have made a 2D vector with length n, and in second dimension we have size 2, n cross 2, and we have initialized it with -1. Now we will supply it. Let's apply this v, and also to this function. Okay, now what we have decided that if we encounter a value, if we encounter a value, that means our current and which value, and our DEC is not equals to -1. That means this value contains or changed. That means we have already find that value. So we are going to directly return it. We're going to return v DEC, sorry, current and DEC. Okay. Now again here we have to include this call in the call, comma v in here also, comma v. Now what we are first, let's take that if we have called for this, so we have to store this value in this vector. So to store this for the each and every call, what we are going to do, we are going to include it here. So we are going to write v current and our decision is equals to, so we have stored this in this value. So whenever next time we need this, we can directly check it and return, so we do not have to do this multiple times. So this is how memorization is going to minimize our calls and save from TLE. Now let's try to run it and check if there is any error or something. So it is working fine. Now let's submit it and check it if it works. Okay, so it works very nice. Okay, so now let's move to our next approach, which is tabular approach. So this approach is just opposite to our recursion part. So in recursion we have moved from up to down. So in this we are going to move from down to up. So it is down up approach. So we are moving from right hand to left hand. So in this, what we are going to do, we are going to use a function max profit, which uses a 2D vector to store our maximum profit at each index and at every decision flag. So it fills the table iteratively from the left to right. So in the recursion, we are filling from left to right, and here we are going to fill from right to left considering the buy sell decision of each deal. The maximum profit is calculated by comparing buying or not buying on the current day. The final result is obtained from top left cell of the table. So finally, what we are going to do, we are going to run our calls, and we are going to start from the last index or the right hand side of our right hand side of the array, and our output is going to be our leftmost cell value. So it is going to our final output. So let's see how we are going to write this tabular form and how it is written. So what we have to do is we have to start from our condition. So our condition is this, that our if our current is equals to price dot size, we have to return 0. So here what we are going to, we are going to store it directly. We are going to store v n, and let's make this size more. So at vn, uh, and at 0 is equals to v and 1. So at both decision, if we have stock previously or no stock previously, we have to make it equals to 0. So that's how we are going to start. Now it is going to be very simple. We are going to have to iterate throughout the loop. So we are going to start from previous, we have to start from the right hand side. As I mentioned, that recursion and tabular are just opposite of each other. If we are moving from one direction in recursion, then we have to move opposite in the tabular. So we have to move opposite. So we are going to take int I, which is going to start from n minus 1, and which is greater than equals to 0 until I minus minus. Now we have to run another for loop for our decision, and here we are going to take let's take this variable to be current for our ease. You will understand why I am doing this. So here let's take the same, which is DEC is equals to 0, DEC less than equals to 1, DEC plus plus. So we have used the same variable which we have used in recursion, because let's see how we are doing it. We are going to just copy from this to this part. Simple. We are copying and pasting here. So this is all which we have to do. Done. So we have to done little bit changes, and all code are going to be same. So this is how is the tabular is going to be. So we have to change this check to our dp. So what we have to do here, what we have done, we have buy the stock. So we are going to call it for next, which is the for our parent plus 1, and we have to check the value present at position where it has been wide. So in this check we have to just change it to check the value present at v parent plus plus, that is the next value, and we have not buy the stock, so it is going to be 0. Now similarly you have to change this also. So let me just copy this. So here what you've done, we have sold our stock, so our second parameter is going to be 0 because we do not have any stock, and our in here our second parameter will be 1, which is already 1, so no changes are required. So this is the code, and one thing we have to do is that whenever we move to the next loop, before that we have to store what we have to store. We have to store current, and this value is going to be dec is equals to maxi. So we have stored, and finally we will return which value. We have to return the value are finally found at the first position, which is v0, and 0. 0 why? Because the first position, from the starting, we have already discussed that when we start from this position, we do not have any stock earlier. So this is similar as the previous one. So now let's try to run. Okay, we have to comment it first. Let's comment this part. So this is commented. So it is already running because we do not have called the function yet. So now let's try to submit this code. Okay, so it is successfully submitted. So now we have discussed about the two approaches. First is recursive and memorization, and second is tabular. Now let's look at the third approach, which is going to be space optimized approach. So in here we are going to reduce our space more, and we are going to use a constant space almost. So the here what we have to do, we have to the function max profit optimizes space uses by keeping track of only the previous day's profit about buying and selling decision. So if it trades from the second last day to the first day and updates the profit value based on decision made on the current day. The various days profit are updated from the next iteration. The maximum profit is obtained from the final profit for buying the decision. So let's understand from this. Let's remove this first. So currently what we are doing, we are using this vector and storing in here, and you will already understand what we are doing. So what we are going to do in this space optimization approach, so in here you can clearly see that what we are doing, we are just using the previous one values or the next one values present from the current. So for the current value, we are using the value present as the current plus one, and for similarly for every, we are just require the value next to it. So by using this insight, we can decrease our space. So what we are going to do, we are going to just store the next value present to our current. So for taking 2D vector, we are going to take a simple vector. Let's take a simple vector v, and its size is going to be 2 with value, let's take it 0. And let's take another vector for our current. Let's take it c, and value is going to be 2 and 0. So these two are the two size vectors, and here we have to some changes. So here only v and v. So the first index, and this is for starting what we are doing, we are first initializing our last index 0 and 1 parameters, which is our decision parameter equals to 0, and we are using the same loops, everything is going to be same. Similarly, we are just going to change it here. We are going to use only v and we are just using the value next to it, because we have not required any value more than that. So instead of storing it in v, we have to store it in our c variable c, and here our dc. So we are storing the values for the c for every loop, and after completing this internal loop, what we have to do, so once the loop is completed for the any value, so we move to the third position. So after completing this, when you move to the third position, before that we have to copy this. We have to copy v equals to c. So what happens, we are copying the current value which is stored in the c vector to the v value. So next time, the next so the value stored in the v is for 6. So finally what we have to do, we have to return v0. You know why we are returning v0? Because 0 indicates that we do not have any stock value, which is the actual value we need for the first. So now let's try to run this code. Okay, accepted. Now let's try to submit this. Okay, so it is successfully submitted. So in this question, what we have learned? So in this question, we have seen the three approaches. So the first is the recursion. We have first written the recursive approach, in which we have written the recursive algorithm. And then we have integrated the memorization, in which we have reduced the number of recursive calls to make the time complexity less. Now again, we have used two methods or optimized it for the reducing the space complexity. So first we have used the tabular method, in which what we have done, we have used, here you can see. So what we have done in the tabular method, so in tabular method we have decreased the extra space which is being used in the recursion. So we reduced that in the tabular form, and in the last we have also optimized the extra space used by the 2D vector to constant extra space. So the space is optimized to be constant. So it is the most optimal approach and the optimal solution, a space optimized approach, which we have done in last. So this, that's all for this question. Thank you all.